Hello friends, now we are going to discuss about hypothesis testing. So before jumping into hypothesis testing, I want you to learn about a variable. So what is a variable? Variable are values used to describe feature of a sample or data set are called variable. There are two types of variable, quantitative variable and qualitative variable. Quantitative variable are further classified into discrete variable and continuous variable. The simplest difference between both of them is that the discrete variable cannot contain values beyond a point, whereas continuous variable will have values beyond a point. So, discrete variable are variables that can only assume whole number value. Example, number of students 22, 23, 24. Number of students can't be 22.1, 22.2, 23.4. So, it number of students are discrete quantitative variable. Continuous variable are variable that can assume any real number value, simply meaning that it contains values beyond points. Example, temperature can be 98.4, 99.5, and so on. So, temperature is a continuous quantitative variable. Qualitative variable are further classified into nominal and ordinal. Nominal are without natural order, whereas ordinal have a natural order. Example, pain severity, pain may be mild, moderate, and severe. Similarly, we have independent variable and dependent variable. A independent variable is a variable that is not dependent on other variable or which can change. For example, smoking exposure. Dependent variable is one variable with a value that depends on another variable. For example, in a lung function, so we can say that lung function is as a sort depend on smoking exposure. So in this example, independent variable will be smoking exposure and dependent variable will be lung exposure if we want to look a relationship between smoking exposure and lung function. Hypothesis. Hypothesis is a proposed explanation, a testable statement between variable. If we give some statement and we want to show that whether this statement is true or false, so our that statement can be classified as hypothesis testing. Suppose we want to look for relationship between ACE inhibitor and stroke. So we say that ACE inhibitor reduces the risk of stroke. So this is our hypothesis. We have to prove it that whether this statement is true or false. For this purpose, hypotheses are classified into two: null hypothesis and alternate hypothesis. Null hypothesis show that there is no relationship between the variable. It is represented by H naught. So we have in null hypothesis we show no relationship. So we will say that ACE inhibitor does not reduces risk of stroke. Whereas an alternate hypothesis relationship exists between variable. It is represented by H1. So we have alternate hypothesis have relationship. So we will say that ACE inhibitor reduces risk of stroke. So, hypothesis testing. Using the process of statistical test, we have certain tests which we can use to evaluate a hypothesis and decide whether we have to accept the null hypothesis or to reject the null hypothesis. In hypothesis testing, we use certain values like p-values and alpha value. So what is a p-value? P-value is the probability that result happen by chance, assuming null hypothesis is true, whereas alpha value is the maximum probability of making a type 1 error. Normally, we take alpha value as 0.05. So interpretation of statistical result. If p-value is less than alpha, then null hypothesis is rejected. If p-value is greater than or equal to alpha, then we fail to reject null hypothesis. The null hypothesis is rejected when there is relationship between two measured values, and the null hypothesis is accepted when there is no relationship between variable. So let's me dive back into the example. So, after proving, applying certain statistical test, if we show that there exists a relationship between ACE inhibitor and stroke, so then we will reject the null hypothesis and the alternate hypothesis will be accepted. So, null hypothesis is similarly is written over here that the null hypothesis is rejected when there is a relationship between two measured variable, and the null hypothesis is accepted when there is no relationship between two variables. Similarly, if our statistical test show that there is no relationship between ACE inhibitor intake and stroke, then our null hypothesis will be accepted. We can encounter certain errors while testing statistical test, there are two types of error, type 1 error and type 2 error. Type 1 error is that when null hypothesis is rejected when it is actually true, and consequently the alternate hypothesis is accepted, although the observed effect is actually due to chance. It is denoted by alpha. So let's look into the 4 by 4 table. We said that we have a difference calculated as statistically significant. That is, we have a statistically significant, our test results show that there is a statistically significant difference between the two things, but in reality, there is no true difference. Then it is a type 1 error. So let me revise it again, that our tests show that there is a statistically significant difference between the two variable, but in reality there was no true difference. Then it is a type 1 error. So what is type 2 error? The null hypothesis is accepted when it is actually false, and consequently the alternate hypothesis is rejected even though an observed effect did not occur due to chance. It is denoted by beta. So in type 2 error, we have difference calculated as statistically not significant. We show it means that we show that there is no difference between the variable, but in reality there was a true difference. Then it is a type 2 error. So type 1 error is one when we show that there is a statistically significant difference between variable, when in reality there was none. In type 2 error, we fail to show that there is a difference, but in reality there was a true difference. So it is a type 2 error. So type 2 error can be, so power of a study is the probability of rejecting null hypothesis. Power of a study can be increased by increasing sample size and increased precision of measurement. So what are as I told you that there are certain common statistical tests. So the common statistical tests are t-test, ANOVA, Fisher extract, and chi-square test. And when to use these tests, I will show it in this table. So I already told you that there are two types of variable, independent variable and dependent variable. Independent variable can be qualitative and quantitative. Similarly, dependent variable can be qualitative and quantitative variable. So if we have independent qualitative variable and dependent qualitative variable, then we use chi-square or logistic regression test. Similarly, if we have a qualitative independent variable and a dependent quantitative variable, then you use t-test, ANOVA, and linear regression. So, also, if we have a quantitative independent and qualitative dependent variable, then we use logistic regression test. And if we have a quantitative independent and quantitative dependent variable, then we use correlation or linear regression test. So what is a t-test? T-test check mean difference of two groups. For example, comparing blood pressure of two person. When we use two quantitative when we compare quantitative mean of two groups, then it is a t-test. We have three types of t-test: independent, paired, and one sample. Independent or unpaired t-test compares means of two separate groups. Example, blood pressure of person A and person B. So if we compare mean of blood pressure of person A with person B, then it will be an independent t-test. In paired t-test, we compare means from the same group at 2 points. Example, if we measure blood pressure before and after treatment in the same patient, then it will be a paired t-test. So, it means that we measure the one reading, yeah, one mean at two different points, like we test before and after a certain procedure. One sample t-test mean compare the mean of a simple group to unknown population mean. It is the mean blood pressure of patient in a clinic different from, if we from the national coverage. We please compare the blood pressure of a person to the national average of mean blood pressure, national average mean blood pressure, then it will be a simple t-test. ANOVA, when we compare mean of three or more groups, example, blood pressure mean of three ethnic groups, one-way ANOVA and two-way ANOVA. In one-way ANOVA, we have one independent variable, whereas two-way ANOVA, we have two independent variable. So chi-square versus Fisher extract test. Both are used to check differences between two or more percentages or proportion of categorical outcome. So mainly we use chi-square and Fisher-Extrakt test for qualitative variables. The only difference is that chi-square are used for large sample, whereas Fisher-Extrakt are used for small sample size. So summary of statistical test, if we have, I'll always show you that we have one dependent variable and one independent variable. Dependent variable may be categorical or qualitative and quantitative. So if we have qualitative dependent variable and qualitative independent variable, then we can use Fisher-Extrakt and chi-square test, but it depends on sample size. If we have small study sample, then we will use Fisher-Extrakt test. If we have a large study sample, then we will use chi-square test. If we have dependent qualitative variable and independent quantitative variable, then we will use logistic regression. Similarly, if we have a quantitative dependent variable and qualitative quantitative dependent variable and qualitative independent variable, and we compare mean of two groups, then we will use a t-test. If we compare mean of greater than equal to two groups, then we will use ANOVA test. If we have not categorical or quantitative dependent variable and non-categorical or quantitative independent variable, then we will use correlation or linear regression. That's all for today. Thank you so much.